Okay, let's look at problems like 7 and 9. So I'm going to do number 8. I think I did number 10 in class. We want to write each fraction as a terminating or repeating decimal. In this case, we have 5/11. This is a complete calculator problem. We do 5 divided by 11. Okay. Hit enter, and it's going to output something like this. 0.45454545. I don't know how many 4 5s it'll give you. It might round one of the 4s to a 5 and so on. But essentially that means that that is equal to 0.45 repeating. Okay, for problems like 11 and 13, these are calculator problems too. So I'm going to do 12. 12 is 3.004. You can do it a long way with dividing by moving the decimal place, dividing by 1,000, etc. Something of that sort, or multiplying by 1,000. But I'm just going to put in the calculator. So just type 3.004 into the calculator. You're going to hit the math button. That's on the left side, about halfway or right underneath the. I don't remember. It's on the left side of your calculator if you're using a TI-84. The first option is an arrow that points to frac. So it looks something like that. You want to select that. So once you get your cursor on that, and it starts on that, just hit enter or 1. And when that happens, what should show up on the screen is 3.004 arrow frac, and at this point we want to hit enter again, and when it does that, it's going to output something, and in this case it outputs 751 over 250. So that's your answer. 751 over 250. Okay, so I'm going to go ahead and just do 16, 18, 20, and 22 because they're all a little bit different, some varying in difficulty. We have 0.5 repeating. So we're just going to let x be equal to our original. That's pretty much a standard step. We do that all the time. 0.5 repeating. I have one number repeating. 5 is repeating. So I can multiply by 10x, and that gives me 5.5 repeating. Okay, that just all I did was move the decimal place one spot, and then there's a lot more 5s repeating after that out in here, this place. Okay, so we're going to take this, we're going to do 10x, and I'm going to subtract x. Well, that's equivalent to taking 5.5 repeating and subtracting 5 repeating, or 0.5 repeating. So I'm going to do that process there, and I get 10x minus x gives me 9x, 5.5 repeating minus 0.5 repeating. The repeating parts cancel, and I get 5, and so my answer is, dividing by 9 at the last part, x equals 5 ninths. That's what we get for 16. 18. 18's a little bit different because I don't have the repeating part isolated after the decimal. So I need to move it 2 places to start with. So if I'm going to let x be equal to 0.083 repeating, moving it 2 places, that gives me 100x is equal to 8.3 repeating. And then I've got one repeating term, one repeating number. 3 is repeating, so I need to do 1,000x, one more decimal place, 83.3 repeating. Okay, so that's that stuff and that stuff. So we're going to take those two, and we're going to do some subtraction here. I'm going to say 1,000x minus 100x is equivalent to 83.3 repeating, and that's equivalent to 8.3 repeating. and I subtract, and I get 900x is equal to 75. Remember, the 0.3 repeating cancels, and so 83 minus 8 is 75. And so x is equal to 75 over 900, or if you simplify that, that's equal to 1 over 12. Looking at 20. 20 again is slightly different. It's got two numbers repeating, but it's already got the terminating part or the repeating part after the decimal, so I can let x be equal to that. I've got two numbers repeating, so I do 100x, so 127.27 repeating. So now I take those two things, 100x, which is equal to 127.27 repeating, x, which is equal to 1.27 repeating, and I do my subtraction here, so I get 99x, okay, 0.27 repeating, cancels, 127 minus 1 is 126, so I get x is equal to 126 over 99, or if I reduce that, I get x is equal to 14 over 11, because both things are divisible by 9. Okay, and then if we look at 22, 22 is 1.101 repeating. Okay, that's 3 digits repeating. You have a problem like that, and so we're going to take this and we're just going to say, since this isolated part is already repeating, or the part after the decimal is already the repeating part, but I have 3 decimal places. So 3 decimal places means I need 3 zeros, so it's 1000x, 1101.101 repeating. I take 1000x, which is equal to 1101.101 repeating. I take x, which is equal to 1.101 repeating, and I subtract. Okay, 1000x minus x, that's 1000 minus 1 is 999x. The repeating parts cancel, which is the point of this, and now I have 1101 minus 1, which is 1100, and that does not reduce. You get x is equal to 1100 over 999.